know how to differentiate the functions in your mathematics 3. First of all, we have some rules like d respect to dx for the exponential function e to the power f of x. So it's equal. The differentiation of any function in form of e, it will be copy paste. All of that times the differentiation of the power, which is f prime x. That rules coming in the exam like that. D respect to dx for e to the power of x, it's equal e to the power of x only. It's given like that in the formula sheet. So the second rule, the differentiation of ln f of x. So if you have differentiating of ln, we just do that. That function, f of x, write it down in denominator. And up, we just differentiate that function. That rules coming in the exam in that form, d respect to the x for ln x, it will be equal down x, and as you know, derivative of x, it will be 1. But you need to attention for that. Then, the third rule, it's the derivative of sine f of x. Then the derivative of cosine f of x. How to differentiate each of which is sine and the cosine? The derivative of sine in general will be cosine for that function. Then we just multiply by the derivative of inside, so it will be f prime of x. Also here, the derivative of cosine, it will be negative sine for f of x. Time differentiation of inside, which is f prime of x. Then the derivative of sec or cosec f of x and sec f of x. The derivative of sec, it will be sec for the same angle time tan. Sorry for that. The derivative of cosec first, it's a negative cosec f of x times cotan f of x, all of that time the derivative of inside. The derivative of sec, it will be sec f of x times tan f of x time derivative of inside. And as you know, always we have relationship between sec and tan, and also relationship between cosec and the cotan, because that functions both have the same denominator. Then we are going to know how to differentiate the rational functions, which is tan x or tan f of x, and the derivative of cotan f of x. So everyone know that the derivative of tan, it will be sec squared f of x time derivative of inside, which is f prime x. The derivative of cotan, it will be negative cosec squared f of x time derivative of inside, which is f prime of x. But everyone know that. Maybe he want to ask to prove how to get the derivative of sec and the cosec, and how to prove the derivative of tan and cotan. We did that before. Sec and the cosec differentiated using the chain rule, and tan and the cotan using quotient rule. So we will back now for the derivative of tan inverse for f of x. It's not looking like tan. I have difference between tan and tan inverse. The tan inverse, we differentiate it as you see now. We have fraction line, down 1, plus that function f of x, all squared, and up the derivative of inside. So all that given in the final exam without function, with function is x inside only. So here it will be the respect to the x for sine x. So it will be cosine x. Here it's given in the exam derivative of cosine x. It will be negative sine x. So the formula given in the exam like that. So if you want to complete the formula in exam, we just exchange every x by f of x. You can do that. That x, it will be f of x, and we multiply always by the derivative of inside. And also we have another rules, like the product rule, and the quotient rule. What's the meaning of the product rule? Product rule refers to the multiplication of two different functions, each of which in terms of x. So if you have a function y equal multiplication of two different functions, one called u and another one is called v, each of which in terms of x. So that means I have product rule. Quotient rule means if you have division of two different functions, that in numerator it's called u in terms of x, and that in denominator it's a v in terms of x. So that means I will use quotient rule. How to use it, mister? It's so easy. How that? We just do that, u first, then v, then differentiate u and differentiate v. So the derivative it will be u times v prime plus v times u prime. Here it's necessary to start from denominator. So v first, then u, then v prime, then u prime, and divide all of this by v squared. So here the derivative of the product rule, it will be dy respect to the x equal u times v prime plus v times u prime. Here the derivative in quotient, it will be, first of all, I will do fraction line and in denominator v squared. Then v times u prime minus u times v prime. So we noted that the derivative here starts with v, ended by v, divided by v squared. So it must be starting from v, which is denominator. So forever, that is the all rules you need to differentiate any function in grade 12. Now, we'll back to our questions to know how to use that rules. First of all, you need to read the question very well to decide which rule you need to start with. What is the differentiation? It's dy over dx. It's y dash. It's f dash. It's the gradient. Okay, what is the difference between the gradient and dy over dx? The gradient, it's dy over dx at a specific point. And that gradient always represents the gradient of the tangent. So, let's go to start that. Find dy over dx. Did you have any product rule? No, no multiplication here. But the function is sine, so I will start to differentiate dy over dx. It will be equal. The differentiation of sine, it will be cosine for the same angle. Nothing change for the angle. Then we just multiply by the differentiation of inside here. 2 times 3, it will be 6x. I said before, only that function involving ln. You need to check first if you need to simplify or not. What is that function? I have to ln x to the power 3, and as you know, ln every time drop the power. So it's still y. I'm not differentiate yet. I just simplify 3 times 2, it will be 6 times ln x. Now start to differentiate. dy respect to dx, it's equal. The function here is x. The derivative of x is 1 times 6, it will be 6. Here, fx it's equal negative cosine. So to differentiate that, dy over dx, the derivative of cosine, it's negative. Times that negative, it will be positive. Derivative of cosine, it will be sine 3x. But the function inside has derivative 3. So that is my final answer. In second question, he said the curve with the equation y equal e to the power x squared minus 1 passes through the point with the coordinates 1 and 1. Letter A, find the expression for dy over dx. So to find the derivative or dy over dx, we just looking to the function first. What is the type of that function? It's exponential function. And I told for everyone before differentiating, you should be rewrite the question to looking like the formula. It's e to the power, no problem. So dy over dx, we know that. For any function involving e, we just copy paste. Then differentiate the power. Derivative of x squared, it will be 2x. Then, he said find the equation of the tangent to the curve at 1 and 1. He said here what? The equation of the tangent. I have big difference between the gradient of the tangent and the equation of the tangent. Equation of the tangent, to find it, always we need two things. Point x1 and y1 as you learned it in grade 11. And gradient of the tangent, which is dy over dx at that point. Now, we just need to use the given. In the given, he gave us 1 and 1, so that is x1 and y1. Now, we need to find the gradient. I find dy over dx here. So the gradient of the tangent, it's equal dy over dx at the given point, where the value of x equal 1, so x equal 1. So that means we exchange every x by its value in the original function. It will be 2 times 1, sorry, not in the original, in the gradient of the function. 2 times 1, it will be 2. Times e to the power, exchange x by 1, it will be 1 squared minus 1, it will be 1 minus 1. So that is equal. Using a calculator, e to the power 0 is 1. 1 times 2, it will be 2. So that means the gradient of the tangent is equal to. So that point, and that is the gradient of the tangent. And everyone know that. The rules is y minus y1 is equal m of the tangent times x minus x1. Now we just substitute y1 and x1 from x1 and y1 and the gradient of the tangent in that equation. So it will be y minus y1, it's equal 1. M of the tangent, it's equal 2. Times x minus x1, which is 1. Now simplify more, so y minus 1 is equal. Distribute that by every term. 2 times x, it will be 2x. 2 times negative 1, it will be negative 2. So finally, we're just shifting negative 1 to other side. So y is equal to x minus 2 plus 1. It will be minus 1. That is the equation of the tangent. Then we put hashtag we love math. Then, differentiate x cubed minus 2x times ln x with respect to the x. What is the type of the function? That bracket times ln, so that refer I have multiplication of two different functions, correct? Each of which in terms of x. So that means directly we're going to choose or to use product rule. Why? Because I have multiplication of two functions, each of which in terms of x. So we name one of them as u and the other is v. In product, no problem to start from any one. So the first one in the bracket, because it's more than one term, keep it inside bracket, x cubed minus 2x. Second one, no need to make it inside bracket. Now start to differentiate first one using that rules in grade 11. So 3 times 1, it will be 3x to the power 2 minus differentiation of 2x, it will be 2. V dash, the derivative of ln x, it will be 1 over x. Now we apply the rule. How that? U times v dash. So I have two terms here, distributed for that. So it will be dy respect to dx is equal. Now multiply every term. X cubed divided by x, it will be x squared. Negative 2x divided by x, it will be negative 2. Plus. Also ln x here one term and that more than one term. So it's distributed by multiplication. Also 3x squared times ln x, it will be 3x squared ln x. Minus 2 times ln x, it will be negative 2 ln x. That is my final answer. Always when we finish the answer, we back to the question to know we find everything or not. Now we are going to the next question. He said, the function f(x) is defined as, show that the graph intercepts the x-axis at the point 1 and 0 and 2 and 0, and find the gradient at these 2 points. The gradient here means I will differentiate then substitute. But what about that function? It's ln x times all of this. X here greater than 0, that refers to x is a positive value. Okay, if x intercepts the x-axis, everyone know that. If the curve intercept with x-axis, so that means y equals 0. And if the curve cuts, or the curve intercept with y-axis, so that means x is equal to 0. He said here, show that the graph intercept the x-axis at that point. So intercept with x-axis, so that means y equal 0. And the y represent f of x. So f of x equal to y. So we just put that here. X squared minus 4x plus 4, all of that times ln x equal to 0. Why? Because it's intercept with the x-axis, so that means y equals 0. If it's in cuts y-axis, so that means every x it will be 0. Now multiplication of two functions, each of which equals 0, that means maybe the first one equals 0 or the second one is equal to 0. And everyone knows that ln x equals 0. To remove ln, we just take e as a base, so x it will be e to the power 0, so x it's equal 1. Here to solve that, it's a quadratic equation. Using mod 3, you will got the values of x. So we just insert in my calculator. If it's 95, Mod 3, 3, 1 equal negative 4 equal positive 4. So the answers, it will be 2 and 1. So the points here, x is equal 2 and 0 because anything cuts x-axis, y equals 0. And also here x is 1 and y equals 0. So the both point with an x-axis. Now I have 2 points. He said find the gradient at that point. So to find the gradient of that points, we need to use the product rule because it's a multiplication of two different functions. So I got here u is equal x squared minus 4x plus 4 inside bracket, and v is equal ln x. So find u dash, derivative of x squared, it will be 2x minus 4. Keep it inside bracket because it's more than one term. And the v prime here, it will be equal x down the differentiation of x, it will be 1. So we just apply the formula now. So f prime x equal. In the first one, we just distribute every term here. X squared divided by x, it will be x, minus 4x divided by x, it will be 4, plus 4 times 1 over lx, it will be 4 over x, plus, now we take that, ln multiplied by every term also, 2x times ln x, minus 4 times ln x. Now, to find the gradient at 2 points, means I'm going to the first one and the second one. In the first one, we are replacing every x, that is x, by its value, which is 2. And the second one, we're replacing every x by its value, which is 1. Then use a calculator to find the answer. Here, it will be 2 minus 4 plus 4 over 2. We're replacing every x by 2. Plus 2 times 2, it will be 4 times ln 2 minus 4 times ln 2. So I will get the answer using a calculator. Also in the second one, we exchange every x here by 1. Only x. So it will be 1 minus 4 plus 4 over 1, it will be 4 plus 2 times 1, it's 2 ln 1 minus 4 times ln 1. So use a calculator to find the answer. So as you know, ln 1 equals 0. It will be equal positive 1 here. The first one, it will be 0. So I got the full answer. Now we are going to that question. Show that if fx is equal 1 over a times tan inverse x over a, then f prime of x is equal. That question from past exam papers, I think it's not repeated again, but we will start to differentiate it according to the rule. Everyone knows that the derivative of tan inverse, that is the function, right? The question given and the answer is given, so that means you need to find the answer, then write it to be looking in that formula, then compare. First of all, to differentiate that function, we just do that. F prime of x is equal. 1 over a is a constant. We didn't look for it. And I said that before. 1 plus, keep that here. F of x, all of that, squared, x over a all squared. And the up derivative of x over a. X over a in mathematics means 1 over ax. X over 2 means 1 over 2x. So the derivative of x over 2, it will be 1 over 2. And also the derivative of x over a, it will be 1 over a. So the derivative of that, it will be 1 over a. So we just multiply that, it's a numerator by that. So when we multiply, it will be 1 times 1, it will be 1. A times a, it will be a squared over 1 plus. That power distributed for division, it will be x squared over a squared. I said before, if you have any denominator to remove it, we just multiply all terms by that denominator. So I will multiply all terms by I squared, or A squared, sorry. Here I will multiply by A squared, and here by A squared, and here by A, all terms. So that cancelled. That cancelled. The other, we just multiply them together. So it will be, the remaining up is 1. 1 times A squared, it will be A squared plus X squared. That is my final answer. It's proved. Nothing else. Next question. Differentiate y equals sine times for 3 minus 2x squared. It's only sine. So everyone know that the derivative of sine according to the rules, it will be cosine for 3 minus 2x squared. Time differentiation of inside. It's better to keep the derivative of inside bracket. Derivative of 3, 0. Derivative of negative 2x squared, it will be negative 4x. So that is the final answer, nothing else. Next. Here, he said find d respect to the x for the following functions. I have a lot of functions here. First of all, we need to decide the type of the function first. So, in the first one, that is product rule, because it's a multiplication of two different functions, each of which in terms of x. So I will use u and v. We name the first one u, which is 4x squared. The second one, it will be v, which is ln 5x. Now start to differentiate. The derivative of u, grade 11, 2 times 4, it will be 8x. Here, I will differentiate that. The function down is 5x. The derivative of that function, it will be. So 5 divided by 5 cancel. The remaining, it will be 1. Now start to simplify or to use the formula. Apply the rules only. So it's equal, or dy respect to the x is equal, u times v prime. So 4 times 1, it will be 4. X squared up divided by x down, it will be x. In product rule, we do that, it's plus. 8x times ln 5x, we cannot multiply that x by that x, because that 5x inside ln, not outside. So 8x multiplied by the all functions, 5 little x. Some students do that. They multiply 5x by 8x, we cannot. 5x here inside ln. So that is my final answer. Hashtag we love math. And the second one, it's the only rule for e. And as you know, to differentiate e, we just do that, dy over dx, copy paste 5e to the power x cubed times the differentiation of the power 3x squared. Now, multiply a number with a number. 3 times 5, it will be 15 times x squared times e to the power x cubed. For the third one, f of x equal cosine 2x to the power 4. So f prime x, no product rule here. It will be derivative of cosine. It's negative sign, and keep space always to derivative for derivative of inside. Negative sign 2x to the power 4 times derivative of inside, that 4 times 2, it will be 8x to the power 3. That is my final answer. Next question. We have a lot of things here. Find dy over dx for each of the following. I have here cosine. All of this represent an angle. No problem. Plus sine. Also e here represent an angle, the inside functions. So we just follow the rule. No product rule. So dy over dx is equal. The differentiation of cosine, it will be negative sine for x squared minus 3x plus 7. Mr. Why you keep all of that space? Because I have differentiation of inside will be more than one term, so it must be inside a bracket. The derivative of inside now, that differentiation of x squared, it will be 2x. Differentiation of negative 3x, it will be negative 3. Plus, now we start to differentiate sine. Derivative of sine, it will be cosine. That is my angle. Time derivative of inside, for E, it's copy-paste. And derivative of the power here is 1, and that is the final answer. We just follow the rule. Next, here I have multiplication because that fraction or that bracket involving x and that also involving x, so that is product rule. We notice it if you have multiplication of two different functions, each of which in terms of x. So we will do that. U is equal more than one term, keep it inside bracket, 4 cosine x minus 3 sine x. V, it's the other one, it will be e to the power 3x minus 5. U dash, derivative of cosine, it's a negative sine x. Derivative of sine, it's a cosine x, 3 still. And the more than one term, keep it inside bracket. The differentiation of v here, it will be copy-paste. Derivative of the power, it will be 3. Now apply the formula, dy respect to dx. It's equal from here. That one term, that more than one term. So I will multiply the term by every term here. 3 times 4, it's 12. Cosine x times e to the power 3x minus 5, slowly. Now we multiply it by the second term. Negative 3 times positive 3, it will be negative 9. Sine x times e to the power 3x minus 5. Plus, here also one term, here more than one term, we distribute it. Negative 4 times e, it will be negative 4 sine x times e to the power 3x minus 5. Negative 3 times e, it will be negative 3 cosine x times e to the power 3x minus 5. Now we're just collecting. Did you have any like terms? Yeah, because here sine times e and here sine times e, that is like terms. We're just adding or subtracting their coefficients. And also here 12 cosine x times e minus 3 cosine x times e, it's like terms. So we're just collecting the coefficient 12 minus 3, it will be 9 cosine x times e to the power 3x minus 5. Negative 9 minus 4, it will be negative 13 sine x times e to the power 3x minus 5. Also, you can take e as a common factor if you need or not. It's back for you. Next one. Also, I have multiplication of two different functions. So, you can practice alone by make that u here is equal, that bracket, x cubed minus 4x squared plus 7, v is equal ln x. U prime, derivative of that 3x squared minus 8x. More than one term, keep it inside bracket. V prime, it will be derivative of ln, the function down, and derivative of x, it will be 1. So using the rules directly from here, dy over dx, it will be equal. Here more than one term, we distribute every term by that. X cubed times 1 over x, it will be x squared. For x squared divided by x, it will be 4x. 7 times 1 over x, it will be 7 over x. By the same way, we just do that in the other direction. 3x squared times ln x, it will be 3x squared ln x. Minus 8x times ln x, it will be minus 8x times ln x. Thank you. Here I have y is equal ln 5x divided by x, so that is quotient rule. Why it's quotient rule? Because it's a division of two different functions, each of which in terms of x. So we name the numerator as u, the denominator as v. And I said before, in quotient rule, you must be starting from denominator. So v is equal x and u is equal ln 5x. Now start to differentiate x, it will be 1. The derivative of ln 5x, 5x down. The derivative of 5x, it will be 5, so that it's cancelled. All of that divided by v squared, which v is x squared. Now start to differentiate. So dy over dx. You can state the answer from here. First of all, x squared down. Then v times u dash. X times 1 over x, it will be cancelled, it will be 1. Minus, don't forget that. In quotient, I have here minus. 1 times ln 5x, it will be ln 5x. That is the final answer. Also in the second one, it's a division of two different functions. So that is u, and here is v. Always we start from v. V is equal sine 2x. U is equal 5x to the power 7. V prime, the derivative of sine, it will be cosine 2x times derivative of inside, which is 2. U dash, derivative of 5x, 7 times 5, it's a 35 times x to the power 6. All of that divided by v squared, which is sine. The squared, it will be here, not for the angles. So we can find the answer from that. So dy over dx, but you need to show all of that, over, I have here in denominator sine squared for 2x. Up, v times u dash, we just multiply. We cannot multiply the angle inside with x outside. So 35 times x to the power 6, it will be 35x to the power 6 times sine 2x. Minus 5 times 2, it will be 10 x to the power 7 times cosine 2x. So that is my final answer. If you want to make common factor up, it's no problem for that. 35 and 10 both divisible by 5. X to the power 6, x to the power 7, so the smallest power is a common. Then open bracket, divide every term now by that common. 35 divided by 5, it will be 7. X to the power 6 divided by x to the power 6, it's cancelled. So the remaining in the first term, 7 sine 2x, minus 10 divided by 5, it will be 2. X to the power 7 divided by x to the power 6, it will be x times cosine 2x. Then hashtag we love math. And next one. Y equal 5 cosine 3x squared minus 1. No product rule because no x outside. So the derivative of that dy respect to the x, it will be equal. Differentiation of cosine, it will be negative sine for 3x squared minus 1. And that 5 is still here. The derivative of inside bracket here, 2 times 3, it will be 6x. And differentiation of 1, it will be 0. Negative 5 times 6, it will be negative 30. X times sine for 3x squared minus 1. Next question, we need to simplify. Why? Because I know that from chapter 1, e to the power ln x cubed, it's cancelled. So everyone know that e to the power ln x, it will be equal x. Here, e to the power ln x cubed, so y is equal x cubed. Now start to differentiate, so dy respect to the x equal 3 times 1, it will be 3x squared. It's finished. And I have here hint for everyone. If E not involving functions, so its derivative will be 0. For example, if you want to find d respect to the x for e to the power 3, I differentiate here respect to x. Did you have x in the function? No. So that is constant, and as you know, the derivative of any constant equals 0. Also, for example, if you have to do that, d respect to the x for x times e to the power 2. X here down, and that without x, so it's a constant. So that looking like the differentiation of 2x equal 2. Differentiation of 3x equal 3. So that also it will be e squared because it's represent the coefficient of x. Now we are going to the next question. In the next one, we have the function equal for x cubed times e to the power 2x. So to differentiate that, f of x equal 4x cubed times e to the power 2x. It's product rule. Test yourself. It's product rule. Multiplication of two different functions in terms of x. Test yourself. Next one. Y equal ex squared times sin x at x equals 0. Also, it's a product rule because it's a multiplication of two different functions, each of which in terms of x. So we name the first one u, which is e to the power of x squared. The second one, it's v sin x. So what about x equals 0 at the end when we finish differentiating? Now start to differentiate. Derivative of ex squared, copy paste the derivative of the power, which is 2x. V prime, the derivative of sine, it will be cosine x. So dy respect to the x is equal e to the power x squared times cosine x plus 2x times e to the power x squared times sine x. He said find the gradient at x equals 0. So we just exchange every x by 0. So it will be e to the power, we're replacing every x by 0. That is x. 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 So we just substitute now e to the power 0 times cosine 0 plus 2 times 0 times e to the power 0 squared is 0 times sine 0. So the final answer here, 0 times anything, it will be 0. That is cancelled. E to the power 0 is 1, and cosine 0, it will be 1 times 1. The final answer, it will be 1. Now, we are going to some questions like this. Find the gradient of the normal to the curve y equal ln 3x, where x equal 3. He said here the gradient of the normal. The gradient, it's dy over dx. At a point, give me the gradient of the tangent. He didn't ask me to find the equation of the normal. He just asked me to find the gradient of the normal. And everyone knows that the gradient of the tangent is dy over dx at the given point. But the gradient of the normal, we can state it from the gradient of the tangent by changing the sign and the flap. So first of all, dy over dx is equal the function ln, so 3x down. The derivative of 3x, it will be 3, so that cancelled. So it will be equal 1 over x. So the gradient of the tangent, it's equal dy over dx at the given point where x is equal 3. So it's equal 1 over 3. Now to find the gradient of the tangent, of the normal, sorry, from the gradient of the tangent, how? Change the sign. It's positive, it will be negative. Then flip 1 over 3, it will be 3 over 1, so it will be negative 3. That is nothing else. But if he asks me to find the equation of the normal, so I will use that formula, y minus y1 equal m of the normal times x minus x1. But here he said only the gradient of the normal, not the equation of the normal. Next one. If f of x equal cosine x, find the gradient of the curve at x equal. So the gradient at the curve, it's f prime. We didn't have here any product rule because 5, not x. So to find that, f of x is equal cosine x. But that function is what? ln 5x times f dash times f what? Dash. So how to find that f dash? How to find it? From f. F is given. So find the f dash here. The derivative of cosine, it will be negative sine x. So that function is changed to be y is equal 5 times ln x times f dash, which is negative sine. Negative times positive, it will be outside, not between. Sine x. Now I have product rule. So u is equal negative 5 ln x. V is equal sine of x. So u dash, derivative of that, x down, derivative of x, 1 times negative 5, it will be negative 5. V dash, derivative of sine, it will be cosine. Now dy, respect to dx, it will be equal negative 5 times cosine x times ln x. Positive times negative, it will be negative 5 over x times sine x. Now he said when x equal pi over 2, just substitute negative 5 times cosine pi over 2 times ln pi over 2 minus 5 over pi over 2 times sine pi over 2. And everyone know that in the circle of unity, pi over 2 equivalent with 90. So that point, it will be 0 and 1. So cosine equals 0, that it will be 0, and sine equal 1 times 5 over 2, it will be, using a calculator, negative 5 or 10 over pi. I think that. Past exam papers. Derivative respect to dt for e to the power t squared. Any e, it's copy paste. Time derivative of the power, it will be 2t. Does it 2t times e to the power t squared? It's the first one. In this question, I have two terms involving ln. So I will differentiate each of which. The first one, x down. The derivative of x is 1 times 2, it will be 2. Plus, the second one, 3x down. The derivative of 3x, it will be 3. So I noted that 3 divided by 3 as a factor, it will be 1. So that means I have 2 over x plus 1 over x. Sum of two fractions with like denominator, so the denominator is still. And we're just adding the numerator 2 plus 1, it will be 3. So the answer will be 3 over x. That question from grade 11. How that, mister? If you have more than one term in denominator, so that refer to I have bracket to the power 1. So it's a chain rule. Switch that up to write it to be looking like the principal formula. So 4 times that bracket, if you change that to be up, it will be negative. The inside is still x squared plus 4x plus 1. You studied chain rule in grade 11. We just multiply power by coefficient. Negative 1 times 4, it will be negative 4. I have the same bracket, x squared plus 4x plus 1. Reduce power by 1, it will be negative 2. Times the differentiation inside. Derivative of x squared, it will be 2x. Derivative of 4x, it will be positive 4. Differentiation of 1 is 0. Now, simplify more. The power here is negative value, so it goes down to be positive. X squared plus 4x plus 1 all to the power 2. Now start to simplify up. Negative 4 multiplied by every term here. Negative 4 times 2x, it will be negative 8x. Negative 4 times positive 4, it will be negative 16. Did you have it? Yeah, that is negative 8x minus 16 over x squared plus 4x plus 1 all squared. That is the third choice. In that question, it's implicit function. Why? Because it's involving x and y together. He said the gradient, so I want to differentiate. And I told you that in implicit function, how to know it? It's a function involving x and y together. And so hard to make one of them as a subject. And everyone know that if you have x times y, or x times dy over dx, or x to the power n times y to the power n, all of that represent product rule. Also, if you have y times dy over dx, that represent product rule. So, to differentiate that functions, I have multiplication. U equal x squared, and v is equal y to the power 4. In implicit, we differentiate x normally. Derivative of x squared, it's 2x. Because we differentiate respect to x. But for y, we just do that. 4 times 1, it will be 4, y to the power 3, then multiply it by dy over dx. Now apply that to differentiate. X squared times 4, it will be 4 x squared y cubed times dy over dx plus 2x times y to the power 4, all of that is equal. The differentiation of 4, it's a constant value equals 0. And to find the derivative of any implicit functions at given value or at a given points, we just substitute by replacing x by its value and y by its value. So I got here 4. What is the value of x? It's 2 squared. What is the value of y? It's negative 1 cubed. All of that times dy over dx is equal. Plus. The value 2, value of x 2, value of y negative 1 all to the power 4. All of that is equal. Now the gradient represented by the value of dy over dx. So we just do that. dy over dx. Evaluate that first. 2 times 2, 4. Negative to the power even is positive, or insert all of that in your calculator. You will got positive 4. Then shifting it to other side, it will be negative 4. Also divided by that coefficient. Negative 1 cubed, it's negative 1. 2 squared is 4 times 4, 16. It will be negative 16. So the final answer using a calculator, it will be positive 1 over 4. That is. And next question. That is the differentiation of Ln. And as you know, the differentiation of Ln, the function down. The derivative of that function, 2 times 2, it will be 4x. But everyone noted that we didn't have that choice. So we need to notice if you have any common factor. Yeah, all of them have common factor 2. So we just divide the all terms by 2. 4x divided by 2, it will be 2x. 2x squared divided by 2, it will be x squared. 2 over 2, it will be 1. I think now I have the answer. 2x over x squared plus 1. 2x over x squared plus 1. I think we have mistake here. 2x squared plus 2 down, derivative of that it will be 4x. The whole function divisible by 2, 4x divided by 2, it will be 2x. 2x squared divided by 2, it will be x squared. 2 over 2, it will be 1. So 2x over x squared plus 1, I think that is. That it will be the answer. Some mistakes here. Next question. If k is a constant and the derivative of that, if you got any question and answer, just differentiate and find the answer in the same form of the given. So the derivative of e, it will be copy paste. Differentiation of the power, it's negative 1. He said all of that is equal 5e to the power negative t. Now if you divide e with the e cancelled, so negative k equal 5, but I want to find the k or negative k, k only. So k is equal negative 5. We divide by negative 1. And the next question, the differentiation of a, it's copy paste. Differentiation of the power 3. Here he said the gradient of the tangent to the curve y equal, x cosine x, it's product rule. And he said the gradient of the tangent, so we just do that. U is equal x and v is equal cosine x. How to note that, Mr.? It's multiplication of two different functions, each of which in terms of x. So start to differentiate you first. Derivative of x is 1. The derivative of cosine, it will be negative sine x. Now, the gradient, it will be y dash or dy over dx or f prime, all the same. Start to simplify. X times negative, it will be negative x sine x plus 1 times cosine x, it will be cosine x. He said where x is equal pi, we just exchange every x or substitute every x by pi. So negative that pi, sine pi, plus cosine pi. Change your calculator to be radians, then insert all of that to be in final answer. So I think that points on the circle of unity, it will be negative 1 and 0. So the final answer here, it will be negative 1.